Alright, I've had a question in 4U Physics Unit 2, lesson number 4. It's question 53. So we see that we have a collision going on between a series of balls here. So we know that the initial or all our total momentum is coming from the first ball here. So we know mt, vt is coming from that. And after the collision, we have m1 that's right there, m1 v1 plus m2 v2. So there is the momentum equation set up. Now because we have an angle, we know that we are dealing with two-dimensional, so we're going to have to go to our vector addition. So the way I'm going to set it up is that I'm going to have this as my resultant, and you can set this up a variety of ways. It's not the only way to do it. So I'm going to take the momentum of ball 1, and the momentum of ball 1 is, I believe, right there. So it's going to be, and we don't have an angle, so it's an unknown. So we're going to have m1 v1 cos theta I plus m1 v1 sine theta j. And then we're going to add the momentum of ball number 2. And that one is m2 times 4. Oops, and it's a negative because it's going in the negative direction on the x-axis. Goes 25i. Plus, it is going upward, m2 4 sine 25j. That's all equal to our final momentum, or momentum total, that comes from that initial ball. It's heading upwards, so it had no I component, and plus m1, its mass, times 6, and the angle would be 90 degrees, so it'd be just 1. So there we go. Now the nice thing with this, because of this statement right here, the masses are all equal. That means that when we look down the columns mathematically, m1 and m2 will end up canceling out, and so those masses there. So now we want to know the final velocity here, so we are looking for v1. So we look down the columns and decide, which value or which column provides us with the most information. So let's look at our x column here, or the x component. So from it, I have v1 cos theta plus 4 cos 25 equals 0. So if I rearrange that a little bit, I can get that v1 equals negative 4 cos 25 over cos theta. So I still have two unknowns. So now what I'm going to do, I'm going to go ahead, I'm just going to move that down there, look at my y component, see what that gives me. So my y component is v1 sine theta plus 4 sine 25 equals 6. So I can do a little bit of isolation here. So 6, take away the 4 sine 25. So that gives me v1 sine theta equals 4.3. I just got to go back to the x component for a second there. It should have been a negative 4 over here. I forgot about my negative sign there, which means it would be a positive over there. Over here then, v1 equals 4.3 sine theta. So I have two expressions here to solve for. They're both equal to v1. So that means that therefore 4.3 sine theta equals 4 cos 25, which is just a number, over cos theta. So I'm going to rearrange it. 4.3 4 cos 25. Multiply the sine theta up here. And the reason I do that, we know that sine theta over cos theta is tan theta, and the other one would become for cos 25, 1.19, let's say. So we know our angle then, shift tan inverse of my answer, gives me 50 degrees. So I can take that 50 degrees and I'll go up to the x component. So V1 equals 4 cos 25 divided by cos 50. So we find out that our velocity, bracket 4 cos 25 divided by cos 50, that comes out to be 5.64 meters per second. There we go. So it's a situation where we had, if I go back to the top here, we've got two unknowns. We don't know the velocity and we don't know the angle. So that means we're going to have to do kind of a substitution in order to get there. And unfortunately, solving for the angle first is probably the easier method. All right. If you have any questions further to this, let me know, and I'll try to give you a hand.